All right, in section 4.3.2, we'll be looking at integration by parts for definite integrals. So we'll do the same thing we just did for a substitution. We'll do it for integration by parts. I just want to teach you what to do with the bounds when you're doing integration by parts. All right, so let f and g be differentiable functions. Then the integral, let me do it with f and g because I'm really trying to to prove a point in some sense. So it would be f of x, g of x, and then the prime would switch from the g to the f. All right, so our mantra, our slogan, our rule was that we change the bounds when we change our variables. But if you look, all of my variables are still x. So I'm not going to change my bounds. They'll still go from a to b because it's the same variable. X is going from a to b, that's it. But I have to put in the bounds. And so I'm going to put a and b here. And then this one will be evaluated at a and at b. All right. So if you want to write it with u and dv, that's fine, and I'll show you how. But you have to remember, even though they're u's and dv's and v's, which look like different variables, we're not actually changing variables. When we write the functions, they're still in terms of x. So that's why for integration by parts, we keep a to b and a to b. All right, so let's try an example. This is going to be our last example of this section, which is very exciting. All right, so I want to evaluate the integral from 1 to 2 of x squared plus 1 times e to the 2x. All right, if you remember integration by parts, I have an algebraic function because I have a polynomial, and I have an exponential. So Lie8 tells you to take the x squared plus 1 as your u. And then I'm going to take e to the 2x as my dv. Because it's an a versus e, I know I'm going to differentiate until I get rid of the x's, so that's going to take me 2 steps. So first I'm going to get 2x, second I'm going to get 2, and so I need to integrate this one twice. So I'm going to get e to the 2x divided by 2, e to the 2x divided by 4. All right, and now I'm taking these with alternating signs, and then I'll be having one last plus with an integral. All right, so my integral will be x squared plus 1 e to the 2x over 2 minus 2x e to the 2x over 4 plus the integral of 2 e to the 2x over 4. Right, let me put in the bounds. I'm going to put them with a stick when there's no integral left, and then I'm going to just put them on the integral for the last part. All right, so in this case, I'm going to plug in 2. I'm going to get 5 e to the 4 over 2. If I plug in 1, I'm going to get 2 e to the 2 over 2. All right, I'm going to need to plug in 2. And I'm going to plug in 1. All right, so this last one I haven't integrated yet, so I need to integrate. I need to get rid of the integral sign. And so this is what I'm getting from 1 to 2. And so I'm getting 5 e to the 4 over 2 minus e to the 2 minus e to the 4 plus 1/2 e squared plus e to the 4 over 4 minus e to the 2 over 4. All right, so let me put all the e to the 4 together. I'm getting 5/2 minus 1 plus 1/4, so that is 7/4. And then if I look at e to the 2, I'm getting minus 1 plus 1/2 minus 1/4, And so that's minus 3/4 e squared, and that's it.